Okay, so we have this system of forces here. Okay, now in this situation, they are asking us for the magnitude and direction of the resultant force. Okay, so they're not in equilibrium, they're not balanced, but essentially we go about the same approach. Okay, so we have a situation where we have our cross. Okay, and we are then going to resolve the forces, okay, in the x direction and the y direction. So we've got here 56 newtons going in the x here, 27 going in the y, in this y direction, and then 78 in that y direction. It's this, obviously, one that's going to cause us a bit more of an issue, isn't it? Now, in regards to resolving this, you just need to appreciate it's going in that direction. So that's sort of like going in the x this way and then in the y this way, yeah? So you need to have a component going this way and a component going that way. Now, what you need to appreciate this time as well is that the alpha, the angle alpha here, is contained with the y direction. So it's going to be 60 cos on the y-axis there, right? And then, of course, then it'll be the opposite then. It'll be 60 sine alpha in the x direction, okay? Now, we've got to somehow work out what cos alpha is, what sine alpha is, because we don't know what they are. However, what they do give us here is they tell us that tan alpha is 3/4. And you just need to appreciate that tan alpha, okay, is opposite over adjacent, yeah? So with the SOHCAHTOA, GCSE, trigonometry, we know that tan is opposite over adjacent. So if this angle is alpha, the opposite side would be here, so that would be the 3, wouldn't it? It would be the value on the top, okay? And then the adjacent would be the value on the bottom here, 4, okay? And then you could work out that side by using Pythagoras. And of course, Pythagoras would say this is 5, because 3 squared plus 4 squared, add them is 25, square root it, and you get 5, okay? So it's obviously known as the 3, 4, 5 triangle as well. But what's good is then you can work out what cos alpha is. So cos alpha is adjacent over hypotenuse, so that will be 4/5, and so you can work out sine alpha. So sine alpha is opposite over hypotenuse, which is 3/5. Okay, so when we then look for a resultant force, they're not balanced, okay? And that's important to remember. We can't say this is equal to this. What we say is we look at the resultant force in the x direction, okay? And we just say, look, 56, to consider that as the main force, the leading force. Take away then the resistance, which is 60 sine alpha, okay? So we can work that out, can't we? Because we know sine alpha is 3/5, so we can put that in. So we get 56, take away then 36, and we get 20. In the y direction then, we've got, to consider this then as the leading direction, 60 cos alpha plus the 78, those two combined, take away then what's opposing it, 27, okay? And of course then that will be 60, well cos alpha is 4/5, because we worked it out at the top there, plus 78, take away 27. So if we do that on our calculator, we get 99, okay? So what you need to appreciate now is in our x direction, the resulting force is 20. In the y direction, the resultant force is 99. We can then combine these to consider the overall resultant effect. So if you think about it, in the x direction, we've got going 20 this way. In the y direction, we've got a much bigger force of 99 going that way. So overall, the resultant is going to be going sort of this way, okay? Yeah, because you're going across 20 and then you're going in the y direction then 99. So what we can do then is to work out the resultant, we can consider the overall effect of this, so the triangle that's created. So because you go in 20 this way, 99 this way, you can then work out R, okay? Because the triangle has been formed 20 that way, 99 that way. So you've got a triangle there. So use Pythagoras. 20 squared, add 99 squared, and square root it. And that will give you R. Okay, so on my calculator, if I do that, I get 101 newtons, exactly. So that's my resultant force. To get the direction, we just need to work out this angle here. Okay, the angle that it creates to the x direction. It's clear then, labelled on our diagram, we mean the x direction here. And of course we can use trigonometry here, so we can use tan, can't we? So tan theta, opposite over adjacent, 99 over 20. So theta then will be, okay, opposite over adjacent, so theta then will be tan to the minus 1 of 99 over 20. And we get 78.58 degrees, and we can say then to the x direction. So we've got the direction of the resultant force and the magnitude.